This time we will start Mohr circle. So we will learn how to draw Mohr circle and how to use it to determine principal stresses and maximum shear stress, their orientation, and so on. So at the beginning, what I did here, at the beginning, I assumed any arbitrary structure which has different kinds of load. You can see here. Say maybe this is my structure. It has a compression load here, or maybe tension. So okay, it should be tension here and no compression here. Okay, maybe compression here, tension here. Again, do not mislead by this arrow. So there's a tension here, compression here. There is some torque or torsion. So if we take a small element inside my member, say this is my small element, if I make it bigger, it will look like this. Say assume that this element is getting different kinds of stresses. One is compression, axial compression here along x-axis, that is 20. In this way, y-axis I'm getting 90, and then my shear stress here is 60. So if I draw shear stress here, I should draw this way to make it equilibrium, and in this side my shear stress I will show this way. So all these shear stresses are 60. Now this one is compression 20. That means actually I made a mistake here. I should show this way. uh, so I will show erase my arrow here. So compression this way, then compression this way, it will be balanced. Tension this way, then tension this way, it will be balanced. So my section or this element is in equilibrium. Now we will learn how to draw a Mohr circle. Why Mohr circle? Because it is a very easy way to determine the principal stresses and some other parameters we will see. So how to draw a Mohr circle? So it is a circle. So to draw it, we need to know the radius and center. Now what is the center? So we learned that the center of a Mohr circle is calculated using this equation, sigma x plus sigma y over 2. Now what is sigma x? Sigma, if this is x-axis and this one is y-axis, so any stress uh, any stress this way is sigma x and this stress is sigma y, that is the normal stress. So average of this is my center. So my center, and something else also. What is the sign convention? Sign convention is this normal stress, this normal stress, this normal stress. If it is tension, it is called positive. So if normal stress is tension, it is a positive. Now what about shear stress? Shear stress is on the right side of the cube. If the shear stress goes up, that means this shear stress is 60 up this side, it is a positive. So if this goes down, then it will be considered negative. That is the sign convention commonly used to draw Mohr circle. So for our case, what is sigma x? Sigma x is this 20. So 20, and is it positive or negative? It is a compression, so it is negative. Then what about sigma y? Sigma y, if you see that here, this is positive, so it is a tension, that means it's positive, divided by 2. I am getting it is 45. No, it is 35. So we got 35 is our center of the circle. How do we find it? This is our equation to find the center. Now we'll see how to find radius. So radius, the equation is sigma x minus sigma y divided by 2 square plus shear stress square. So this is the equation to find the radius. What is my sigma? Sigma is minus 20, and then what my sigma y? Sigma y is 90 divided by 2. Then shear stress is 60. So if I do the calculation, how much it is? 81, sorry, 81.4. So 81.4 is my radius. So I got my center, I got my radius. Now I can draw the Mohr circle. How to draw? So first we have to assume a axis. So horizontal axis we assume axial stress or normal stress. Vertical axis we assume shear stress, and we assume right side of sigma is positive and below of, so downward we assume downward is positive. So that is the sign convention we use to draw the Mohr circle. Now what is my center? My center is 35. So 35, say it is somewhere here. So we got my center 35. Okay, right here 35, 35. What is my radius? Radius is 81. Now to draw 81, so 35, so 81 roughly here. I need some space. Okay, my center is here. So if I draw a circle, it looks like this. So this is my center, and this portion, so my radius is here, so it is 81.4. So we got, now my 0 0 is here. If you are confused, my 0 0 is here, and my 35 is up to this. Okay, so we got my center, my circle. Now we can find all of our values one by one. First, principal stress. What is that? That is the stress where there is no shear stress. There is no shear stress. So if you see that this point has no shear stress, so this is a principal stress. Another point is this point. This has no shear stress. So smaller one we call sigma 2. Is called minor principal stress. Bigger one we call sigma 1. That is the major principal stress. So sigma, now how to find sigma 1? You can see my 0 0 is here, up to this is 35, then from here to here is 81.4. that is my radius. So what is total value here? Sigma 1. So my sigma 1 is 35 plus 81.4, which is 16.4 megapascal. So we got one principal stress. Again, what is principal? We got one principal stress. What about now sigma 2? So sigma 2, how can I find it? We know from here to here is 81.4. Then if we deduct this 35, we will get this one. So this is like a geometric way to find it. Arithmetic way, I know from this point, if I go 35 then minus r, I will get it. So two ways we can find it, or whatever way you prefer. Simply you need to find this distance. That is our sigma 2. So sigma 2 can be found. Sigma 2 is c minus r. C minus r. Now how c minus r? Because if we start from here, c up to this, then minus r up to this, the balance is this. So it is 35 minus 81.4. I'm getting 46.4 and negative, and the unit is MPa. So we got our minor principal stress. What is the other stress? That is maximum shear stress. Maximum shear stress. What is the value of this? Is the maximum value of the shear stress, and shear stress is plotting this way. So this value is the maximum shear stress. And what is this value? Maximum shear stress is always the radius. So maximum shear stress is always the radius. Why? You can see here the radius of the circle. The radius of the circle. See, it is always always the radius. So we found sigma 1. We found sigma 2. We found maximum shear stress. Make sure that you learn how to do it. draw the Mohr circle, and from the Mohr circle find the maximum sigma, minimum sigma. Those are two principal stresses and the maximum shear stress. Next question is how to find the orientation. Orientation means like in this say this is my reference line. With respect to this, where these stresses are located, we can find it using this Mohr circle also. To find it, at the beginning we need to locate a reference line. This line is the reference line. See, this is my reference line. We need to locate this line. How to locate it? We have to see these two stresses. One is -20, then is 60. So -20 plus 60, that is my reference point. How to locate it? Okay, locate in this circle -20. So 0 0 is here, so -20 means somewhere here, then plus 60. Y-axis downward is positive because we assume this is positive downward. So -20 here and then somewhere here. So this is my reference point. It is -20 and plus 60. This point. This is my reference, and if I connect with my center, so this line is very important. This line is actually this line. This line is actually this line. So note it down. So this line is actually that line. Okay, now if I want to find the orientation toward my maximum shear force, so maximum shear force is here, and if I then this angle is important because from the reference line, this is the angle to the maximum shear stress, but this angle is inside my circle. Inside my circle, remember that it is always double. Whatever the angle here, the angle in the circle will be double. So we'll write here twice theta s. Why twice theta? 2 means double, theta means angle, s means the shear stress. So we have to find this angle. Can we find it? Yes, very easy. How? Draw a triangle, this triangle. Now you can see that everything is known here. First of all, what is known? First of all, we know the radius. This is radius, we know it. Do we know this side? Yes. How? From here to here is 35, and from here to here, that means from here to here is 20, -20. So total is 55 here. So this side is 55. Now we know radius, and we know this. We can use sine rule, because sine is opposite by hypotenuse, or even something else. We know this portion also. So here to here we know that. We know this. What is that? That is this 60. Can you remember what is 60? We went from 0 to -20, then 60 here. So this value is 60. So you know all the sides of this triangle. So you can use sine rule, cosine rule, tangent rule, whatever rule, you will find this angle. So let us assume tangent rule. So I like tangent. So tangent. So tan twice theta s is, so tan, this angle, that means opposite by adjacent. Opposite is 55, adjacent is adjacent is 60. So from solving we will get the angle is 42.5 degree. That means theta s is 21.25 degree, and it is, so it is going this way. That means counterclockwise. So that is counterclockwise. So yes, this angle is the angle from the reference point. Reference point is here, and it is counterclockwise, 21 degree. Okay, now how to show it? We just see it here. How to show it? I need some space. To make some space, what I will do, if I don't know how to make some space. Okay, let me try to make some space here, because we do not need the centroid anymore. So make some space here. Okay, so here we make some space. Okay, maybe we need more space, so make more space here. I do not, is there any shortcut to make a good amount of space? Yeah, maybe we can. This should be good enough. Now, what we'll learn from here, that after this angle counterclockwise, we will find the maximum. We will find the maximum uh, shear stress. Okay, then draw. This is was my line, and it will be counterclockwise. That means if I go here after counterclockwise, 21.25 degree. If I draw a cube over there, and what about this stress? Is it positive or negative? It is a positive number because downward is positive. So here my shear stress will be this way. What is this value? 81.4. Okay, to balance it I have to apply force this way, then this, not force, shear force, sorry, shear stress. So all the shear stress is 81.4 megapascal. Now, is there any normal stress here? Yes. Now why my cursor is not working? Yeah. Is there any normal stress here? Yes, because my reference point is here, not reference point, my center. So if I go this way, it is 35 here. So here my 35, and this value is positive. As positive means it will be tension. So 35 here. So 35 here, that means also 35 here. Now what about this side? Do I have any force stress here? I have to find it here or there. Okay, how to find it? Now if you go there, here to here is what is the degree? 90 degree. 90 degree. That means 90 degree clockwise. So if I go here to there, 90 degree clockwise, that means I will go here to up to there, 180 degree. Whatever the angle here, that is double here. So if I go here to there, is 180 degree. And what is the value here? Same value, same line, same value. So here also 35, and that is positive megapascal. So this is my state of condition or state of stress for maximum shear stress. This point I showed the angle. That means inside this member, if I rotate this block this way, I will get my maximum shear stress. Now what about the principal stresses? Yes, we can find this also. So you can come here. This angle was, can you remember how much? It was 42. So if this is 42, this angle will be 90 minus 42.5, which is good question. How much is it? I think 47.5 degree. So this angle 47. Now what is this angle? This angle I can write it twice theta p2. Why twice theta p2? Because it is from the reference point to my principal stress, which is p2, means this 2. Now we found twice theta p2 is 47.5. Then what about theta p2? Is half of this. Half of this is 23.25 degree. And it is how it is going from my reference point, it is going clockwise. That means from my reference point, if I go clockwise, I will get my principal stresses. So I will draw that. So to draw it, let me make some space. Let me make some spaces here. Is there any shortcut to make some space? Let me check whether I know any shortcut or no. If I clean it and then No, there is no shortcut, I think. Okay, check one more time. If I select this portion, no. So there is no shortcut, I think. I will find later. Now, okay, I made some space. Okay, now, what we learn here, that if I rotate 23.25 degree clockwise, I'll get it. So this is my reference point, and if I rotate 23 degree clockwise, 23.25 degree, and then if I draw a cube, sorry, not cube, yes, cube, then I will get my maximum sorry, principal stress sigma 2. What is the value of sigma 2? If you can remember, it is still here 46. So and it is compression negative, so it is 46.4 megapascal. So that is my minor principal stress. So to balance it, I have to apply this one also. Now what about this side and this side? Do I have any stress? Yes. Whatever the value here, if I go 180 degree, whatever the value I will get other side, that is the value here. And that one we found 116.4 positive, that means tension. 116.4 positive, that means tension. So you can see here, if I go here to there, that is 90 degree, but here I am going 180 degree. So whatever the angle here, that is double here. Okay, now do I have any shear stress here or here or here, or what about here? No shear stress, so no shear stress here. Here no shear stress here, so over there is no shear stress. So that is the representation of the principal stress. And where we'll get it? If we go 23.25 degree clockwise, then we will get it. How do we know? From the Mohr circle. So from in the original structure, if we go somewhere this way and draw this cube here, we'll get it, get the principal stresses. So hopefully you understood how to find principal stresses, maximum shear stresses, and how to find their orientation. We could do something else, but this page becomes so messy. We will stop here. In next video we'll see something more. Thank you.